Wattmeter. The wattmeter is an instrument for measuring the electric power, or the supply rate of electrical energy, in watts of any given circuit. Electromagnetic wattmeters are used for measurement of utility frequency and audio frequency power. Other types are required for radio frequency measurements. Electrodynamic. The traditional analog wattmeter is an electrodynamic instrument. The device consists of a pair of fixed coils, known as current coils, and a movable coil known as the potential coil. The current coils are connected in series with the circuit, while the potential coil is connected in parallel. Also, on analog wattmeters, the potential coil carries a needle that moves over a scale to indicate the measurement. A current flowing through the current coil generates an electromagnetic field around the coil. The strength of this field is proportional to the line current and in phase with it. The potential coil has, as a general rule, a high-value resistor connected in series with it to reduce the current that flows through it. The result of this arrangement is that on a DC circuit, the deflection of the needle is proportional to both the current, I, and the voltage, V, thus conforming to the equation P equals 6. For AC power, current, and voltage may not be in phase, owing to the delaying effects of circuit inductance or capacitance. On an AC circuit, the deflection is proportional to the average instantaneous product of voltage and current, thus measuring true power, P equals 6 cos phi. Here, cos represents the power factor, which shows that the power transmitted may be less than the apparent power obtained by multiplying the readings of a voltmeter and ammeter in the same circuit. The two circuits of a wattmeter can be damaged by excessive current. The ammeter and voltmeter are both vulnerable to overheating in case of an overload. Their pointers will be driven off scale, but in the wattmeter, either or even both the current and potential circuits can overheat without the pointer approaching the end of the scale. This is because the position of the pointer depends on the power factor, voltage, and current. Thus, a circuit with a low power factor will give a low reading on the wattmeter, even when both of its circuits are loaded to the maximum safety limit. Therefore, a wattmeter is rated not only in watts, but also in volts and amperes. A typical wattmeter in educational labs has two voltage coils, pressure coils, and a current coil. We can connect the two pressure coils in series or parallel to each other to change the ranges of the wattmeter. Another feature is that the pressure coil can also be tapped to change the meter's range. If the pressure coil has range of 300 volts, the half of it can be used so that the range becomes 150 volts. Electronic wattmeter. Electronic wattmeters are used for direct, small power measurements or for power measurements at frequencies beyond the range of electrodynamometer type instruments. Digital. A modern digital electronic wattmeter/energy meter samples the voltage and current thousands of times a second. For each sample, the voltage is multiplied by the current at the same instant. The average over at least one cycle is the real power. The real power divided by the apparent volt-amperes, VA, is the power factor. A computer circuit uses the sampled values to calculate RMS voltage, RMS current, VA, power, watts, power factor, and kilowatt hours. The readings may be displayed on the device, retained to provide a log and calculate averages, or transmitted to other equipment for further use. Wattmeters vary considerably in correctly calculating energy consumption, especially when real power is much lower than VA, highly reactive loads, e.g. electric motors. Simple meters may be calibrated to meet specified accuracy only for sinusoidal waveforms. Waveforms for switched mode power supplies as used for much electronic equipment may be very far from sinusoidal, leading to unknown and possibly large errors at any power. This may not be specified in the meter's manual.